Bismillahirrahmanirrahim. Welcome to the lecture on file system interface. In this lecture, I will cover the basics of file system, then file access method, and directory and directory structure, and remaining topics like file system implementation and disk allocation methods will be covered in the lecture 10. So what is a file? File is a logical unit of storage, and files can be stored in secondary storage devices. So this is the introduction about a file. What does a file hold? So there are different types of files: programming files, text file, image files, executable code file. So different files have different files stores different types of data. So where is the data stored? Data are stored in the secondary storage device. What structure does a file have? There are, as I said before, there are many types of file. So different types of file have different structures. Example, text file. Once again, let me repeat: the executable code file, which we have discussed in the lecture 7 and 8. Source code is compiled by a compiler into a object code file. Then the object code file goes as an input into a linker, and the linker gives executable code as a output. So that executable code file would have a separate structure which would be different from normal text files. So different files have different structures. Next question: what operations can be performed on file? So to create a file, a system call is used called create. Then after creating a file, write system call can be used to write some data in the file, in a file. Then read operation can be accomplished using read operation is used to read the data from a file. So to read the data from a file, system call, appropriate system call is used to read the data. Then reposition within a file. So what is this? When a program is reading the data from a file, there are, in a file the program would fix a file pointer. So using the file pointer, the application can fix a point from where the reading or writing can start. Example, from the beginning of a file, or in the middle part, or from the end of the file, the data has to be read in the backward direction. So these things can be done using something called reposition within file, that is fixing a file pointer. Then files can be deleted, the size of the files can be reduced. That can be done using truncate operation. Then files can be opened and closed. So while opening a file, we have to pass the name of the file as an argument. While closing the file also, the name of the file is passed as an argument. So now let me show you these operations using a Python code. This is just for understanding purpose, so you need not memorize this Python code, or you need not study this Python code. So you just focus here in the lecture, okay, whatever content available in the lecture. This is just to make you just to show you practically how these things are happening. This is a Python code, okay. So in the Python, Open API is used to open a new file, open a file. The name of the file is excuse me, given as an argument to this open method, and also the mode has to be given as an input to this method. So here the mode is write mode. So if you want to read, or means, then it should be read or W. So the plus actually is given as an argument to indicate that if the file is not existing, then a new file has to be created, and then that file has to be opened. So to facilitate that, this plus is given. So just to make you understand whatever we discuss theoretically, just I am showing how this is implemented through some programming language. Here we are discussing a sample Python code. So this API is used to open a file. So this one is used to write some data into the file, okay. So you can see the program here. This is a simple Python program. Here the file excuse me, abc.txt is opened in the write mode. After that, using the write method, some data is written into this file, okay. So I was telling about the seek, this one. So reposition within a file. So if you want to fix a file pointer in the file, okay, while you are reading, or say here actually there is a file called abc.txt. So this file is opened in the read mode to read the data from the file, okay. So here actually we are using the Python, we are fixing a file pointer, a particular position from where the data read operation has to start. So the position what you want to mention, you can give that as the argument here, okay. So this is the function, seek is the function which can be used to accomplish this task. So delete is all these for each and everything you can find the appropriate methods in all the programming languages, okay. It can be implemented using C or C++, Python or Java, clear. So these are the basic file operations which can be performed on a file. File attributes. Operating system stores some informations about the file in the directory table, such as file name, location, etc. These informations make the file attributes. In elaborate from the book, okay, we can discuss the different file attributes. The name of the file, What type of file? This is a non-readable, non-human readable name. Actually, it is embedded in a file identifier actually. So type of file, okay, different file types are there. So which type this file belongs to, like document, PPT, etc. The location of the file, the size, access control information, and time, date, and other information such as user identifications. For example, let us select this file, properties. So type of the file, Microsoft Excel. Okay, so this file has to be opened with Microsoft Excel. Location, it is stored in C:users. Okay, this is the exact location in the file system. Size, and this is which time this file is created, and what time the file was modified last, what time the file was accessed, and some attributes like read only, hidden. So if you want to make this file read only, you can just select this. Then also you can compress this. Okay, then security, file access permissions. So all these things make the file attributes. Let me repeat: name of the file, identifier, then type of the file, location in the file system, size, okay, access control informations, and time, date, etc. So all these make the file attributes. So in short, we can say file name and type, location and size, protection, and housekeeping informations make the file attributes. So all these informations about a file are stored in a directory table. Okay, so basically the storage device would be partitioned. So we will discuss that concept little later. So when a partition is created, a volume is created, okay, it would have a directory table, a table. So this table, whenever a file is created, the information about that file would be entered in that directory table. So a new file, let's say you are opening a Microsoft Word document or Excel document, and you are creating a new file. So the information about this file would be entered in a table. Okay, that table is called directory table. So for each partition, for each volume, okay, like C:, D:, there would be a separate table. So when the operating system, now you have created a file, so the information about the file is stored in the directory table. Now after let us assume that we close the file and we want to open the file again. So the data is stored in the hard disk. So when the user tries to open that file, so operating system would find the information about the file in the directory table. So using that information, for example, in which location of the hard disk, okay, this particular file is stored. The first block of the file, okay, is starting in which location of the hard disk. So that information should be in the directory table. So using that information, the operating system can initiate the read or write operation from the or to the hard disk. Okay, so this is very important, directory table. So all the informations about a file is stored in a table called directory table. So these are the file attributes. Now let us discuss the concept of memory mapped files. Okay, the files are stored in the secondary storage device. Okay, So let us say we have a Word document or PowerPoint, okay, all these files are in the hard disk. Let us say there is a file a.txt, there is some file in the hard disk, let us say a.txt. Now let us assume there are two programs. This is, let us say for example, two Java programs running. This is two Python programs or any programs, it does not matter. Okay, let us assume there are two Python programs running here. So these two programs wants to share this file which is in the hard disk. Okay, the file a.txt, it is in the hard disk. Now the operating system provides us a facility. What is that? This file, for example, just recall the chapter 7 and 8. Okay, the process are divided into pages and memory is divided into frames, correct? And the process pages are loaded into the frames. So this is how the virtual memory concept also implemented using this technique, paging technique. Okay, just recall that. So the file in the hard disk will be loaded into the virtual memory, will be loaded into the frames. The file which is in the hard disk, let us say a.txt, that file would be loaded into the memory RAM. From the hard disk, the file is loaded into the memory here. Let us say this file is here now. So the process, what they do, Python, let us say the two programs, Python programs, they don't access the file directly from the hard disk. Suppose they want to read the data from the file, they don't directly access from the hard disk. What they do, they access the data from the file from the memory, because this file is loaded into the memory. Okay, so the process, they access the data from the memory instead of accessing directly from the hard disk. So what is the benefit? The benefit is it improves the performance, because the process, they don't directly access the file from the hard disk, rather they access the data, the file data from the memory, main memory. Okay, so this concept is called memory mapped file. So mapping, you are loading a file into the memory so that applications, they access the data from the file directly from the memory instead of from the hard disk. So this concept is called memory mapped file. So opening a memory mapped file causes a region of process virtual memory to be associated with the file. So the file basically is loaded into the process virtual memory, into the main memory. Just try to understand in a very simple manner. The file is loaded into the memory and the process will access the file from the memory. Okay, then read or write to the files are implemented as read and write to this memory. That is, the process will do the reading and writing operation in the memory, main memory, not in the hard disk. So okay, so the process, they will do the read or write operation, okay, in the file which is loaded into the memory. They don't deal with the hard disk directly. Now suppose this process finishes its task. So when the let us say the process calls the file close method, file open, you remember the operations, file operations, open operations, close operations here. So here file close operation. So when you open a file, okay, using open method, you have to close that.
So when a file is closed by the application, so what will happen? So in a Python program you are calling the close method. So you are closing the file. So when a file is closed, what will happen? Whatever data in the file, it would be copied into the hard disk. So the file in the hard disk would be updated with the file in the memory. When it will happen? When this process closes the file, whatever data here loaded into the memory, that will be copied into the hard disk. You get the point? Okay. So this concept is called memory mapped files. So just I want to show you a program. This is a Python program. So please, again I repeat, students, just I want to give you the practical exposure to you. So I just want to show practically how this memory mapped file concept is implemented. So please, let me repeat, you need not memorize this code, you need not worry about this. Let you just try to focus in this, in whatever information is given here. You get the point? Okay. Just you can see here to understand how this memory mapped file concept is implemented using a Java program. So here it is the package. So in this package using mmap memory mapping method, a particular file, okay, let's say the file name is hello.txt, okay, is mapped. Okay, so what this file is in the hard disk. So using this mmap method, this file is mapped, it is loaded into the memory. So this program will access this file not from the hard disk but from the memory, main memory. Okay, so here from the file we are reading some data, then we are writing some data into the file. So the file would be updated in the memory, not in the hard disk. Okay, as of now the file would be updated in the memory. Okay, we are writing some data in this program. No, this particular statement, some data is updated in the file in the memory area, not in the hard disk. So finally when you close the file, what will happen? The file in the memory would be copied to the data of the file in the memory would be copied into the file in the hard disk. You get the point? So please, this concept is called memory mapped file concept. A small correction actually, the memory mapped file program, this is a Python program, not a Java program. In hurry, by mistake I have said Java, so please just note down the correction. File types. So there are many types of files supported by different operating systems. In some operating system such as Windows, the file extension is very important. Like when we create a Microsoft Word document, the file extension has to be .doc or docx. A PowerPoint file means the extension has to be .ppt. So there are many types of files. Executable file means you already know that the file which is ready to execute. It can be loaded and executed, loaded into the memory and executed. Object code, you know, when the compiler compiles the source code, it would give the object code obj. Java program goes as an input into the compiler and the output would be some object code. Source code means like when we type Java program or Python program in any editor, that, and if we save that file, that is a source code. Okay, we can give some shell commands, like we have command prompt. So we have many commands. Okay, so we have many commands that can be executed in the command prompt in Windows operating system or in the Linux. So these commands can be now you can see a.sh. So these commands can be grouped in a file, okay, and that file in the Linux or Unix can be named with the extension .sh, shell commands, okay. Or in command prompt in the Windows operating system, these commands can be grouped in some file with a file extension batch, BAT. So we have text files, it has the extension txt, word processor, Microsoft Word example, DOC, okay. So multimedia files, MP3, MP4. So there are many types of files. So different files have different extensions. So what you have to understand is, some operating systems such as Windows, the file extension is compulsory. Okay, when we create a file, we have to give the file extension. Why? Because the Windows understand from the extension that this file has to be opened with so and so application. How it knows that? It can detect from the file extension. Okay, so some operating systems like Linux or Unix operating system, the file extension is not a mandatory one. Okay, it uses a different mechanism. Okay, from using that it can manage these different types of files. So this is what you have to understand from the file types. Advantages, okay, basic things: knowing the file type, limit the choice of which application can process that file. For example, when we see a file like with extension like MP3, MP4, so we would open some video player, okay, application, and we will try to run that file. Okay, and the disadvantage is no new file format. When any new file type comes, the operating system should know how to handle that new file type. Okay, so that is one disadvantage, is that file structure. Now let us say the internal structure of a file, because there are many types of files and each file has a unique structure. Let us go back to the executable file, this file, executable file, which we have discussed in the chapter 7 and 8. Okay, so the executable code, no, it should have the information which tells the operating system. I mean, the executable file should have some information. What information? This information would be accessed by the operating system. So this information should tell the operating system that when this executable file, okay, is executed, in which part of the memory the data and instructions has to be loaded, and where the logical address is starting, which is it has to give the offset value, starting address. So all these informations has to be embedded in a executable file, executable code file. You get the point? So like that, different files have different structures. Okay, most of the some operating systems support some structures they cannot support all the different, for example, you have n number of file types, and this n number of file types have n number of structures. So the operating system cannot support all the structures. Why? Because then the code of the operating system would become very complex, and whenever a new file type comes, so which has a new file structure, the information about that new file type and new file structure has to be embedded into the operating system kernel. You get the point? So basically most of the operating system, they support some file structures, okay, especially all the operating systems, they support the executable code file structure, whether it is Linux or Windows or any operating system, they will support this file structure exe. Okay, what about other file structures? Okay, so it doesn't mean that all the operating systems support all the file structure, they support minimum number of file structures. So here students, you need not memorize anything, just try to understand different files have different structures. Okay, example, executable file have a separate structure, text file have a separate structure. Okay, all the operating systems, they support one file structure. Which one is that? Executable file structure. You get the point? And as far as the operating system Linux or Unix is concerned, a file is just a sequence of 8-bit bytes, that's all, sequence of 8-bit bytes. Okay, so as far as the Linux or Windows operating system is concerned, there is a huge responsibility on the part of the application to open a file and interpret the content of a file. It is up to the application. So the Linux or Unix operating system, in that part, they don't take bigger role, bigger responsibility. So I don't want to confuse you too much. Okay, students, what you have to understand from this slide is that different files have different structures. Is it clear to you? So some operating systems, all the operating system, they support a specific structure, one particular structure, that is called executable file structure. Is it clear to you? So now next topic, we will go to file access method. Now we will discuss the concept of file access method. There are two file access method. One is sequential and another one is direct file access method. So what is this concept? Let us assume this is a file. So this file, let us say any file. In this file you have some blocks of data. Okay, some blocks of data, block 1, block 2, block n minus 1, and this one is block n. You want to access the block n minus 1 now. You want, in this file, you want to access some data in this particular part, this particular section. Okay, so block, or we can say record n minus 1. As far as the sequential access method is concerned, one cannot directly access this record n minus 1. Okay, so let's say we have some application. That application is going to access this particular part of the data in a file using sequential. So how it will happen? As I said in the beginning, there is something called file pointer. So the file pointer would be initialized either here in the beginning portion or at the end portion. So you can ask, what is this file pointer? You can just take this as an example. So let's say this is a file. So in this file, okay, you want to okay, using this Python program, you want to access the data in this file. Okay, so the sequential technique says, okay, using the file pointer, so using some method, no, you can fix the position from where you know this application is going to start the access. Using some method like seek, the application example here, this Python program can fix the position from where you know this application is going to start the access. So using the sequential technique, the file pointer can be either placed in the beginning position or at the end position. Okay, so what is our requirement? The requirement is we want to access this particular section of the file, this particular section of the data in this file. Okay, so for that, let us say we are going to use sequential technique. So according to the sequential technique, the application example, okay, the application example like Python or something like that, some program has to fix the file pointer, okay, position exactly where you want to start the access. You can fix the position. Okay, the position can be either beginning position or at the end position, and then you would move. For example, the file pointer is fixed here, then the file pointer would be moving in the forward direction, okay, sequentially. Like first block 1 would be accessed, then block 2 would be accessed, then block n minus would be accessed. So sequential technique says when you want to access the block or record n minus 1, you cannot directly go to the record n minus 1. You have to start from the beginning, and then the file pointer has to be moved sequentially from one record to another in the forward direction. Or suppose if you know, using our program, we can suppose we are fixing the file pointer at the end here, then we can move the file pointer in the backward direction also. Either we can fix the file pointer here and move in the forward direction to the specific record which we want to access, or we can fix the file pointer at the end and we can move the file pointer in the backward direction until we find the correct record. Like you know, sequential search data structure, can you remember that? That sequential search, you want to access a specific data in a specific index position. So how you do that? Until you find, you start from the first array index position and then you just move in the forward direction until you find the correct record. You understand? Correct data. So like that, this sequential file access technique works. So a file pointer identifies a record within a file, like we can fix the file pointer in the beginning position or at the end position. So that is what is mentioned here. The file pointer can be moved incrementally forward direction. So it can, file pointer can be fixed here in the beginning and it can move in the forward direction. Okay, so it just incremental forward. Or the file pointer can be fixed at the end and it can come at the backward direction in rewinding, or decremental you know, backward direction. So suppose you know, this sequential file access technique is used in what kind of storage medium? I don't know whether you remember tape. For example, audio cassette, you remember in the earlier in the, we use some radio, in that we use you know, cassette made up of tape, okay, and we play the music. So such kind of medium, in such kind of medium, if there are some data, okay, we can use the sequential file access method to access the data. Second one is called direct file access technique. So in the direct file access technique, the file pointer can be fixed, can be moved directly to the specific position, and we can access the record directly. So no need to fix the file pointer in the beginning or at the end, no need to move, you know, in a incremental forward direction, no need to do that. So a file is viewed as a number sequence of records. Read or write operations can be performed directly on any record. So this is how, you know, the hard disk, when you have a device such as disk, the direct file access technique is used in the device such as hard disk. So when we discuss in the chapter 12, you will understand more about the disk internal structure, like sector, cylinder, tracks, read-write head. So this head move from one track to another track. So all these things you will learn from in chapter number 12. Okay. So this the internal structure of the disk makes the direct file access method very easy. So this is what I want to tell about the sequential and direct file access technique. Now we will cover the last topic in the lecture 9, mounting. To make a file system available, it must be mounted. That is, let us say we have a flash memory. We want to connect that flash memory into the operating system file system, into the operating system file system. Okay. So that process is nothing but mounting. The operating system is given the name of the device. So we have to explicitly say to the operating system what is the name of the device and to which folder this particular device has to be connected in the file system. So this process is called, actually when we put the flash memory in the Windows or Linux, automatically, you know, it would be detected and operating system would mount that device in a default location of any file system. Automatically this would be done. Now I give you one specific scenario. Let's say I have put a flash memory now. I have connected a flash memory now into this virtual machine. So I have went to the USB setting of the virtual machine and I have selected that particular particular USB device. Now I want, when I use the flash memory, I want this flash to be, USB has to be mounted into this specific folder, into this folder beta, in this in the file system. I want to access all the files in the USB device in this particular folder. You understand? Or any folder, whatever you want. Okay, for this example I have chosen this folder. Okay, so how to do that? Okay, so we are going to do the mounting explicitly. Actually the mounting automatically will happen. You need not do anything, it will be happening just like that. So it will be mounted in any location. Okay, so here in the operating system would choose some default location and it would connect the USB device, but here we want to connect this USB device in a specific location. Okay, Again, let me say, this is just to enhance your knowledge. It is enough that you try to understand this concept. Okay, practically you can just see the what I am doing here, so that you can understand very clearly what is the process of mounting. So I have put the flash memory. So I want to know the name of the device. So each device in the Linux is represented by a file name, so that we can find the name of the file using this command fdisk-l, permission denied. So sudo fdisk-l. So this is the hard disk, this is the flash memory. Okay, so this is a flash memory. So the name of the file is /dev/sdb. So this flash memory is represented by this file. Okay, now I want to mount this into our folder. Which folder? This folder. I want to mount in this location. Okay, so mount, so add sudo command mount device. Mount which device? /device/dev sdb1. okay, so mount this specific device into which location? Now you have to give the location. /home user, okay, then beta, that particular location. Okay, some error, just a minute, let me troubleshoot this. Pause and troubleshoot. I think this error might be this additional /sdb1. there should not be / no. So now it's mounted now. So you can see the flash memory is mounted, okay, in this specific folder. So if I put ls, I can see the files. Just let me close and open cd beta. So I can access all the files in the flash memory in this particular folder. So this concept is called mounting. So mounting means making file system available, okay, using the mounting process. So when you want to mount any device into the file system, the operating system, we have to give the name of the device and also the location in which this device has to be mounted. So once it is mounted, we can access all the files from that location. So here remember, this is the name of the device and the location in which this device has to be mounted. So we gave this as the input to a program called mount. This mount program is in the shell of the Linux operating system. Okay, so when we give this two things as the argument, okay, so this device is mounted in this location. So once it is mounted, we can access all the files and folders of the flash USB device from this folder. So with this I conclude the chapter 9 of the file system interface. Thank you very much.